Now we are going to do a very interesting screencast, programming screencast. So what we'll be doing in this programming screencast is to make an evolutionary model. What is an evolutionary model? We have studied three main concepts in this chapter. So the first one is homophily. People who are alike, similar to each other, they tend to become friends with each other. Then we looked at three different kinds of closures: triadic closure, foci closure, membership closure, and we also looked at social influence. So in a graph, in a network of these people keep changing, right? So first of all, new edges keep coming in this network. So when two people look at each other and they find that they are similar to each other, they become friends with each other. So you see that this network is evolving with time. More friendships are coming in this network, and probably some friendships are getting broken also. And then people, they change their properties because of social influence. For example, somebody who was not getting good marks becomes a friend with a topper and starts getting good marks. So we have also seen these kinds of things known as social influence. So we'll try to model all these three things as an evolutionary model. What we'll be modeling is, there is a city, and this city has different kinds of people. Kinds of people in terms of their body weight. So I hope you remember this Fatman hypothesis, which we discussed during the chapter, that beware of your fat friends. If your friend is fat, the probability of you gaining weight increases. So we will be modeling a city in which there will be people with different body weights, different BMIs, and then we will look at all these three phenomena happening over this network. So we will see that we will code it, mainly we will code it that people who are having similar body weight, they tend to become friends with each other. We will be looking at triadic closures also. Two people having same friend tend to become friends with each other. We will be looking at foci closure. So that is, if two people, they are going to the same eat out place, or let's say the same gym, they tend to become friends with each other. And we will also be looking at membership closure. So assume I am a friend with somebody who regularly goes to an eat out place, so I also start going to that eat out place. So all these different kinds of closures. And we will also be modeling social influence. That will be in a more subtle way, which I will tell you. So how does this programming screencast proceed? So first of all, we have this network, and let's say there are 100 people in this network, and these 100 people have some BMIs. So we assign some random BMIs to each of these persons, and then we look at, when the model proceeds, when the evolution continues, people who are having similar BMI, they make more and more edges with each other. And then we also have we'll introduce 5 social foci in this system, as I'll tell you, and 2 social foci out of these will be, one is an eat out and another is a gym, which has a direct impact on the BMIs of these people. So these people, they will be linked to different social foci, and these social foci will change the properties associated with these people. That is, if you are part of a gym, you will be losing weight. If you are part of an eat out place, you will be gaining weight. And then how do we implement social influence? So one of the reasons for social influence, if you remember, was a shared context, right? So if one person goes to an eat out place, I also start going to that eat out place and I start gaining weight. So this is the way in which we'll capture the influence of, will capture the phenomenon of social influence. So I might have less weight, but then over time I might become friends with somebody because of maybe, let's say, a triadic closure. So we have a common friend, and this common friend makes both of us friends, but now this new friend which I have made is going to an eat out place. I am in his company. So I also start going to this eat out place and I start gaining weight. So we will see how do we code such a complex scenario. And one assumption in this programming screencast that we will be taking, although there are many assumptions, one main assumption is that new edges only come with time. previous edges, as in the existing edges, they are not deleted, only the new edges come in this network. But you will see once when we code the entire thing, it's actually very easy, and you can modify this model in many ways. You can have old edges leaving the network, you can increase the number of social foci, you can increase or decrease the number of people, and you can incorporate many new interesting things in this model.